Our next intermolecular force is called ion dipole. Started on the last page, so I'm picking up right here. This is where we get a little bit of information about it. The big thing right here is you won't really see ion dipole forces unless you have ions, remember ions, anything with a charge, dissolved in a polar solvent. And we've looked at how to determine if things are polar before this chapter. If you need a review, it's in the same section as the VSEPR structures. We won't really see these a lot in 1201, so don't get too worried about this, but if you have something that's an ion, like here, the sodium ion, and it's in something like water, and water's polar, then you're going to have an ion dipole force. The negative partial oxygen on water is attracted to the positive ion of sodium, and so that causes an attraction between these two different chemicals. Dipole is the third intermolecular force. The easiest way to know if something's dipole, figure out if it's polar, right? Use your VSEPR structures, use your knowledge of the different elements around the central atom and figure out, is this thing polar? And if it is, we're gonna say it has the dipole intermolecular force. And so if we look down here, we have hydrogen fluoride or hydrofluoric acid. So we have a dipole movement. The electrons are more attracted to fluorine. It's more electronegative. That makes fluorine partially negative and hydrogen partially positive. Well, if we have an identical compound and it's doing the same dipole movement, you can see how the partial negative will be attracted to this partial positive hydrogen. And here is our intermolecular force, and also right here. So it brings them together. The next intermolecular force is called London dispersion forces or London forces. Easy to identify. Every atom and molecule have this type of force. It doesn't have to be an ion, doesn't have to be polar. Everything has it. And what it is, it's fluctuations of electron orbitals. And so since all of these atoms and compounds have electrons, we should be able to see this London dispersion force. If you have to choose what compound has a larger London force, most of the time you are going to be looking for the larger molar mass because those carry more electrons. And the more electrons you have, the more fluctuations and therefore the stronger London forces. So just keep that in mind if you're stuck between two compounds and you need to figure out which one has the most intermolecular forces. Right? So we can see right here, bigger atoms and molecules will have larger London forces. So helium versus krypton, there can be larger electron fluctuations, and krypton has more electrons.